And it looks like the next talk will have two speakers. Second talk about editors today by Emilio and Bhakti.
Hi folks. It's my pleasure to do this talk jointly with Bhakti. We've been having fun and working on this, and actually here, we are here in particular. We're going to present work we've been doing is on a different language server for coq, which has quite a different design, which is called coq-lsp. And in particular, in this talk is about how do we solve one of the most common problems users have, and maybe as people have been asking questions, how many people has found this bad version number when using coq? How many of you have seen the message? I kind of believe then you don't never use coq if you if you never found that. But indeed, that's actually something very interesting in different contexts. And as of today, the experience to work in, one of the things we do is we work with very large theories that are a composition of many other theories. And indeed, one of the main troubles we have is a big pain because there is a lot of manual steps. You need to edit a file, you need to go to type or to click a button in the editor integration is not so good, the coq-C only knows about a file, then you need to go to make or you need to go to do, this is going to integrate poorly, right? And actually the idea is like, the problem actually, and something we were just discussing today, right, is that actually the reason the user experience is really bad and the developer experience is even worse. So this is, of course, if the developer have to in order to improve this, they're going to find a hell. Then actually, I believe this is a reason. There is a lot of codependency. You know, for example, in MathCom, they develop the tactics at the proofs at the same time. I think in coq, we tend to separate things, but actually, I'm not sure this is very sometimes productive. And indeed, something I've noticed, I work a lot on build systems unexpectedly, but something I've noticed is the programming model to integrate a build system with something like coq-C is really bad, it's really complex. You have a lot of races, a lot of process handling, portability issues, you know. General purpose build systems, they adapt very bad to the domain of interactive improvers, and I think Lynn and Isabel people, at least is the people I know more what they are doing, they totally agree with me. Many other people don't, but I think actually many people come to me and say, but you're going to fuse a build server and an interpreter or a LSP server, and actually they come and they say like, the Unix approach works, but actually this is totally, I've thought a lot about that, this is totally false, this is a myth. In fact, try to maintain a bash script. You're going to see, of course, maybe bash, or you're right, or a Python thing which is untyped, and try to maintain that. I give you a bash script and try to maintain to do a change and verify it or test it. It's really complex, this Unix model, it doesn't work so well. In particular, a lot of extremely important things here. Okay, which is, for example, you need to communicate a lot of things. For example, for what Roman is doing, he needs to communicate the warnings, etc. Did you die if you need to do a protocol with the build system to maintain the protocol? So you have portability, like, okay, try on Windows, like try to deduplicate the stuff, try to think when two objects are equal. So really, this is a really bad experience. And indeed, what we are going to discuss is two key ideas, which are also the foundation for the whole server, but actually we're pretty happy with them. And one is an idea that Andrei Mohov promoted, one of the Dune developers. They were at Jane Street. They have experience with very large industrial code bases. So we had this Dune meeting. I was invited just before the pandemic, and actually he told me, and Jeremy, of course, and Rudy, many other people, they gave a lot of insight on this. But they actually told me like there was this big field that fusioning build systems and compilers, incremental computing. And I think they're right. This is still an open research topic, but myself, I'm pretty happy. He knows way more than I do, but I think that was a good approach. And then the reason is how to do that thing with some methodology that comes from before. We have a methodology based on interpreters from before to do set API and to do things in an easy way, in a very maintainable way. Actually, then we developed something called Fletch, which is actually based on reactive incremental interpreters. Here I need to cite Leo de Moura. He gave in a link together, he said like, incrementality is the most important thing for user interfaces. I think he was just echoing what Microsoft VS Code team thinks. But actually that stuck on my head. And I say, I never think about incrementality. It's very different incrementality from parallelisms, you know, sometimes. Anyway, so on top of that, you have coq-lsp, you have also a new coq compiler that can do a lot of things. And yeah, there is a lot of stuff. And then, but the key idea of Fletch, the key idea is the extensive use of algebraic effects. And I'm going to let Bhakti now to proceed to present what we have done to solve this problem of how to never fail in a require.
Yeah, so that magic number error was something I got a lot and never figured out for some reason. And was talking to Emilio about incremental computation, about algebraic effects somehow, and we were like, OCaml 5 has a new algebraic effect system. If you're not aware, algebraic effects are just a way to model suspending and resuming a computation. Pretty simple. But we decided to kind of explore this application domain in coq-lsp. And so what we did was we decided that, like, really, if you hit a require statement, it should just perform a side effect to, like, check the program, to check the file that you're depending on. And so what we ended up doing was pretty simple, but it took a long time to come up with somehow. But if a require statement is encountered during interpretation, we perform this require effect to read the contents of the file. Literally exactly what's on your screen. And this was pretty simple, but basically what makes it interesting is the handler here, and we wanted things to still be incremental, right? So we would ask questions like, is the required document ready? And if it's ready, then you can resume your continuation with the contents of the document immediately. You don't need to do any more work. If the document isn't ready, you want to mark it as pending so you don't accidentally say, hey, this document is ready when it's not. And then you want to add the current document to the reverse dependencies of the required document. And reverse dependencies is just a way of saying what depends on me, not what do I depend on. And finally, you would add the required document to the scheduler queue, and that's just running. So in the background, at some point, hopefully, it gets checked. Okay, that's cool. What does this mean? So we have an idea of a document state, and it's kind of simple. There's only 3 states your document can be in. It's either in the initial state, it's completed, or it's pending, and it's pending on some other file that we're waiting for. And these are literally the only 3 states your document can be in. And we store the state in like a hash table, and we have a bunch of handles that store information about your document. And so with respect to checking, if the state of if I say check this document and it's completed, I really don't need to do it again, which you would be surprised. There's editors that would do that. If it's in the initial state, then all I have to do is check it. And if it's marked pending, then I check whether the document it depends on is completed. And if it is, then I resume the continuation with the contents of the dependency. Sounds really simple. Here's an example. Looks like a lot of text, but all I'm doing is I'm making in document A, I'm making B, which depends on A, and I'm making C, which depends on B. And then I'm making D, which depends on B and C. I say I want to check B. What happens first is it tries to check B, and now it says, well, B depends on A, so I have to check A. And now it tries to check A, but you know that B is in the reverse dependencies of A. You need to keep that in mind. A checks, we're all good, and now we're back to B, which is in the pending state. And finally, once we find out that A is completed, then B can also complete. Now we say check D. D is going to first try to find B, and it finds it, it's completed. It doesn't need to recheck it again. So then it's going to try to find C, and obviously C is going to say, well, I have a reverse dependency D, and same thing's going to happen, and then finally you're going to have B, which is not checked again, which is like the main thing here, that we are really not trying to do the same thing twice. And finally you end, and everything is good. And you might be thinking, what happens when you update a document? Well, we discover our reverse dependencies dynamically. So it's not like at any point I have a full dependency graph of how everything looks. It's really when I kind of look at something, I know what its dependencies are. If I haven't looked at a file at all, then I don't know anything about it. I haven't checked it, and that's fine. I only want to do things not eagerly. I want to do things like just when someone asks for them. It turns out we get we get errors when we have cyclic dependencies for free. This just happens because there is no valid state where we have no valid states for when there would be a cyclic dependency, and this was something we thought we would have to handle manually, but it just happened. When you update a document, you would invalidate it or mark it as pending, as well as all its reverse dependencies. And then there's like a little beacon in your environment to indicate that your environment has changed, so you know that there has been a change that has been made. And like I said, you only check a document when it is demanded, and not like I have kind of a big library and I check all of it at once, as you would if you did make. So yeah, why would I do that? Maybe Emilio will tell you.
Thank you, Bhakti. And a little bit on the evaluation. There is a qualitative evaluation, and well, you will say, what is the point of this? And the point of this is actually, we are advertising this build system because, this prototype Bhakti show is very, very simple. Though, as you mentioned, it's tricky to understand the flow sometimes. But actually, it's a very interesting build system. So it has a lot of options, including a very interesting soundness proof we are thinking about. This is really future work. And it's really efficient, it's a great experience, and it's very portable. So for example, this is going to solve a lot of problems other tools are having. Like for example, Coq. Try to run in the browser a full Dune thing. I tell you it's not, some people like Shah can do it, but not me. And actually, the difficulty is the beacon, this beacon or this kind of tokens of memoization. This is also very tricky in Dune. This is something for now, it's very simple. We need to gather more data. And actually, by the way, like to deploy this in OCaml 4, actually, it's a bit tricky. It's a bit tricky to get this in OCaml 4. And Coq has, for example, now we are stuck to release this, and some problems with the Coq API is very common, right? But in principle, I think we are happy. It was fun, and it's gonna help some projects like Coq a lot. And quantitative, and actually this we put an emphasis on the draft. So I want to advertise this. Benchmarking is very difficult, but actually I got interested in this because already one of the things we build in coq-lsp is very interesting performance tools. Like if I started in Coq, always understanding performance is very tricky. And indeed, so when we build Fletch and coq-lsp, there is a lot of performance info, and I was always seeing require, a problem with require. I found many problems like this in Coq, right? Like nobody's aware, like there are ghost problems. And actually, I don't know what happened, but it was like a question like, for example, the standard library has 585 files. But do you think, okay, sorry, this was supposed to be hidden, but how many times do we parse VO files? Yes, so actually we parse VO files 65,000 times. So even if people tell me, hey, Emilio, this is I said, not so expensive. I can tell you, actually takes like 8% of the build time. That, of course, with this interpreter, we can memorize the require. So actually, it's 8% faster just by, if we didn't have to fight with some stupid API of Coq, it will happen like a very small change, right? For example, for hot, 5.5% of the build time is, we already parse 30,000 files. And I like this example because this is an example like, actually, if you have to do this with Make or Dune, you're going to really struggle, okay? You're going to really struggle because just copying is going to kill you, so you're not going to get this performance benefit. So this is a clear example. Another example I like to, and I will pass the mic to Bhakti to conclude, but is memory use. For example, like coq-lsp was built from the scratch to have multiple files open in the same process space. And for example, like you can do an experiment with this patch enable and without. And I have it on my computer if you're curious. I don't know if we have time today to show, but I'm happy to show in the Tulip. So for example, you import reals twice. So for example, coq-lsp is able to share. So already you have half the memory consumption. Though it is true, like in normal Coq, you can do a bit of GC and you get back, you recover like 200 megabytes. But already look, for example, this really matters. This is another example. The integration is giving us advantage and quite a few more. But I think we are ready for now. I will mention very briefly in future work, actually, This has been discussed in CoqPL more often, but actually thanks to there is a very interesting interaction of the incremental engine with the build system. So for example, imagine you require a file, and then you say, oh, I need to wait for the file to build. So actually coq-lsp can actually build this file very quickly, like just an interface, load the file in memory, and then in the background, fill these holes in such a way like error recovery. This is related to error recovery, so in such a way like it's very simple. You just need to be sure that memorization, that the proof is not filling a hole really, it's a bit different conceptually. So then, for example, you can get all the proofs and you don't need to require your document again. And unless, for example, the proof really changes something global, then it automatically happens. So you need to, the nice thing of this is no special support is needed. Only a patch to coq to separate the state of opaque proofs or not. And the second point?
Yeah, I mean, I'm really interested in this question of how incrementality in an interactive proof assistant differs from incrementality in a programming language. And I think for something that is so interactive, we should be focusing on something like this more. So if you want to talk about it, I'm here. But that's our presentation. Thank you.
And your folks, and stay tuned for the next release that will include this. Yeah.
All right, do we have questions? Yes.
Thank you very much for the talk. So when is the release? When is the release?
Actually, depends on the time we have. I don't know. I think Bhakti, after all this week, maybe needs to rest too a little bit, right? So, but yeah, hopefully, the prototype we're quite happy. So maybe at least I can give you a pull request if you want to try. But I think it's almost ready to release in OCaml 4 here.
Mm-hmm. Thanks. Thank you. I'm always afraid of standard proliferation, so I wanted to ask, what are the input of your system? Do you read a Dune file, a coq project, or is it another file format to know the shape of what you actually need to build?
Well, I can answer that. For now, we only support coq projects, but it's just unfortunately lack of resources. This is not important in this setting. Like we have a model which corresponds to the internal coq model of the libraries, and then we are able to read coq projects, and hopefully, if we get some time, to do projects. This I cannot promise I will have time to do myself, but it's very easy if somebody wants to do that. So in principle, yeah, we can. This is independent of the metadata. You can. In fact, something very important here is inference. By the way, so actually, for example, it's very easy to, because of dynamics of the internals, is you can infer whatever you want. So this is modular, so not a problem. Though you need to map whatever configuration you have, you need to map it to the coq representation. This is the ground. This is the truth. What coq thinks about where the files are. All this, yeah.
So I was wondering one thing from the sketches you showed. It looked like when you hit a require in a file, you will then wait for that dependency to be handled, and then you go on and handle the next require. So if I have like 5 requires in a row, would it do one after the other? Because if I do this in proof general, it will actually build all the 5 of them in parallel.
Well, that's a great question. So actually for now, and this is a strong limitation, at least at this point, is actually we are single-threaded. But in principle, once we support to, and I like that because for JSCoq it's important. But in principle, there will be no problem in doing it in parallel if we adopt like a single, now we have a scheduler queue is linear. So this scheduler queue can become a bit more complex and you could do in parallel. Like, I don't see a problem with that other than, of course, it's a bit more tricky to program. But actually that should be possible in OCaml 5, for example, using, do all the files in parallel. Because actually what the handler does, is if Bhakti goes back to the slide, the handler, it just pushes into a queue. So then in the queue you can in fact like use standard scheduling strategies to maximize. Yeah. So in this sense, you stop the document.
But you will have to go on in the original document after the require. Like usually you couldn't go on because there's something missing. But some of the following commands you can do if it's just another require.
Yeah, that's a great question. But actually, this is a bit more complex. But actually, you can indeed, if you would like to be eager, you can do a speculative execution of the document. But that's a great point. Actually, yeah, maybe that will be necessary. Yeah, so actually that's a great point. But there is no problem. There is no problem in doing that actually, because imagine you interpret this like errors. Imagine you interpret the requires unsoundly. Then when the things become sound, it will recheck itself. So that's okay to do. Yeah.
Okay, thanks again.